All right, well, good morning. My name is Tom Reed. I am the program director for the Energy and Manufacturing in Appalachia program. And today we're going to be sharing a webinar on our energy supply chain overviews. And today we're going to be talking about battery storage. So I'm going to do a short intro and welcome, and then we'll get started with today's presenters. I've got a couple of links I'm going to share in chat. So this first one that I'm going to put up is the link that will take you to download the battery storage report that we're talking about today. So if you have not had a chance to download that, you have time to do it now, or you can wait and do that as soon as the presentation is over. It's not critical that you have it up in order to follow along, but I think it's going to be important for you to have that once you want to follow up on some of the content that you're learning today. So yeah, as I mentioned, I am with the EMA program. We have been around for a couple of years now, and we help manufacturers in Greater Appalachia. It's 156 counties, including all or part of the states of Ohio, Pennsylvania, New York, Maryland, and West Virginia. And so you can visit our website at wemakeithere.org/energy to get all of the details. And we have quite a list of resources, events, programs that I think will be helpful if you are a manufacturer or if you support manufacturing in those regions. I encourage you to, participate and give us your feedback and all of those opportunities. And then the one last link that I'm going to share with you that you can follow up with after the fact is we do have a LinkedIn group that is specific to energy and manufacturing in Appalachia. And I think you'll find some great resources. There's new content every week that is being put up there. So again, encourage you to do that. You can see that today's webinar and on the energy supply chains is just one of many. We actually have 4 reports that are already available prior to today that you can participate in with our natural gas carbon capture, our AI data centers overview, our nuclear, and of course, I know I was going to forget one. I can't remember. We'll come back to the 4th one in a minute. But this was the 5th in our series, and you can see we have 6 more coming up over the next couple of months. We have the next in the AI data centers, power and electrical infrastructure, natural gas, one on advanced cooling, and then a natural gas RNG from anaerobic digesters, geothermal, AI data centers, and steel infrastructure. And then in the hopper, but not currently scheduled, we are working on a natural gas midstream, a merchant solar, hydrogen SMR, and electric grid components. So hopefully you see one or more of these that are relevant to you. And the goal of each of these reports is for a manufacturer to be able to look and make a go or no-go decision on whether they would like to enter or expand their efforts working in that supply chain. So there's a lot of good data. And so today we're going to talk about battery storage. And with us, we have Punit Shetty and Ray Strauss. They are both principal consultants for the Alliance for Manufacturing and Technology, AMT, which is one of the MEP centers for New York State. Both Punit and Ray have worked extensively across New York on supply chains and the battery energy storage systems. So Punit and Ray, I will turn it over to you, and thank you for putting together this great report. Oh, and one last thing I do want to say, if anyone has questions, please, if you click on the Q&A box at the bottom, you can type them in, and then we will cover all of those questions at the end. Thank you.
Thank you. Thank you, Tom. Good morning, everyone, and thank you for joining us today. As Tom mentioned, I'm Punit Shetty. I'm here with my colleague, Ray Strauss, Together, we'll walk you through the current state of the battery energy storage industry, where manufacturers like you can play a vital role. Before we dive into our technical details, I'd like to take a moment to acknowledge the organizations and people who have helped make this session possible. We'd like to recognize the ARC, Appalachia Regional Commission ARISE program, Tom Reed from Catalyst Connection, Matt Henderson for their sponsorship, and then John Cervoni from New York Best, Akash Rauf from CES for their support. Their efforts highlight just how collaborative and rapidly growing the BES ecosystem has become. And with that in mind, let's look at what we'll be covering today. So here's kind of a roadmap for today's discussion. We'll start by grounding ourselves in battery and energy storage system, or BESS, and then explore the rise of the industry. We'll look at the market overview, growth projections, key drivers, fueling adoption, and some of the challenges and opportunities for you manufacturers. From there, we'll dive into emerging technologies, leading developers, and the role of trade associations in shaping the supply chain. We have a lot to cover, and we'll try to finish a few minutes early so that we have enough time for Q&A, where you can ask us about where your business fits into this opportunity. Tom did mention about MEP. So AMT, or Alliance for Manufacturing and Technology, is private not-for-profit organization established in 1988. We are proud to be part of the MEP, or Manufacturing Extension Partnership Program, a national network of centers that deliver service to small and mid-sized manufacturers. Our mission is to provide end-to-end business and technical consulting to help companies grow and thrive. We connect manufacturers to local, regional, and national resources, and we drive economic impact right here in the southern tier of New York. We did a lot of introductions, so I'll keep it very brief. I extensively work with manufacturers across the southern tier of New York State to identify and implement innovative solutions that improve competitiveness, sustainability, and operational performance. And my recent work includes detailed research into the battery and energy storage industry, with an emphasis on market trends and supply chain opportunities, specifically LFP, or lithium iron phosphate chemistry, enabling grid scale storage. And with that, I hand it over to Ray to introduce and take it from here. Ray?
All right. Thank you, Punit. So I have joined AMT just a little over 2.5 years ago. I'm assigned full-time to a fully funded consulting role for the New Energy New York Supply Chain Development Team. It's a small team focused on engaging with New York manufacturers and service providers to help them assist with introducing or expanding their roles and capabilities in the supply chain for battery and energy storage. You can learn more about New Energy New York by going to neny.org. If you want to jot that down, it's something you can take a look at later. The last 2.5 years, I've personally engaged with like hundreds of manufacturers. I'm also deeply and very engaged with New York State economic development agencies and organizations. We're going to be bringing quite a few manufacturers with us and have a New York State pavilion at the Battery Show in Detroit in October. Feel free to look us up and stop by and say hi. We will have manufacturing and service providers, as well as economic development people with us. My background is solely in manufacturing, previously unrelated to batteries or battery energy storage, and running mid to large scale manufacturing operations. My focus was always on driving product and earnings growth, and I've been responsible for manufacturing operations around the globe. So let's look at the next page here, Punit. So what is battery and energy storage? We've all seen, either from the internet pictures or in real life, the cargo-like containers deployed in various locations identified as battery storage. While often looking closer, we can see that these containers vary in design, size, and shape. However, we'll review that they generally contain very similar systems and subsystems. We'll also review the value and purpose that these solutions provide, and a better understanding of where existing manufacturers can fit in the supply chain. So we actually dig inside of these systems. We have seen some very common subsystems and a vast opportunity to become part of the supply chain. To start, I should point out that the outer containers are usually not standard cargo containers, but they're purposely designed and manufactured custom for their application and OEM. Generally, these systems start with battery packs or racks or stacks of them. These packs, racks, or stacks are electronically managed with multiple levels of what's called a battery management system, or BMS. These systems monitor the state of charge, temperature, and general health of the system all the way down to the individual battery cells. These systems also couple with a power conversion system that controls and alters the AC and DC current conditions, as well as voltage up and down, modifying voltage up and down as needed, and ensures the proper frequency is maintained. You can also see that there's a number of other ancillary subsystems commonly deployed in these applications, such as HVAC, gas and temperature monitoring, as well as other items that support interconnections with the grid or renewables and present supply chain opportunities as well. Next page. So the heart of a battery energy storage system starts with a cell. And for this presentation, we'll be referring to lithium-ion cells, but we'll also cover that there are other chemistries and emerging chemistries, as well as other energy storage types. Lithium-ion cells are typically packaged in one of three different form factors. We are showing a cylindrical cell, but there are commonly alternate form factors such as pouch cells and prismatic cells. We do see prismatic cells, which are larger and rectangular in shape, are becoming more and more common in future battery energy storage system applications. Cells are then grouped together in serial and parallel connections, scaling up the voltage and energy capacity into modules. The modules are then grouped together along with other functional components to create the packs. Those packs are deployed into their applications, and in our subject case here, battery energy storage systems. I'd like to point out that in my somewhat limited exposure over the last few years, that there are a lot more pack manufacturers in the US than there are cell and module manufacturers. Often these pack manufacturers are optimizing their designs for their specific application and then utilizing mainstream existing commercially available cells and modules from a smaller leading group of cell manufacturers, often not domestic. However, this trend is changing over time. Next page. So packs vary in how they look, and in some cases, they're made bypassing the formation of a separate module, but they all typically include current carrying items in the form of bus bars from stamping or progressive stamping manufacturers that connect the cells or modules. There's temperature sensors, BMSs, which are printed circuit board assemblies with voltage and state of charge, temperature, and communication capabilities. There's insulation, vibration dampening, and gaskets from material converters, and housings, both internal and external, from molding houses and metal fabricators, and sometimes from metal extruders. As we saw in the overview and cutaway of the battery energy storage system on the previous slide, there are metal fabricated racks that hold the stacks that these packs connect, the power cables, as well as additional enclosures that include the next level of BMS monitoring and various stacks of the whole system. These subsystems and enclosures are typically fabricated metal enclosures containing circuit board assemblies, wiring, and displays. These, as we saw, connect to a power conversion system with components from similar suppliers, and sometimes including the introduction of supercapacitors that help with the delivery of the power and help extend the battery cell life. The future demand of battery energy storage systems will continue to expand. We've all heard and seen about grid deficiencies and the need to expand and improve the grid. Often that solution takes a lot of time and money, and frequently a solution using strategically deployed battery energy storage systems can be done much quicker and at a much lower cost. The grid is intended to support the momentary peak demand that may only happen for a very short duration of time and infrequently throughout the year. In many cases, grid upgrades can be avoided or delayed by utilizing battery energy storage systems. Additionally, as we know, there are and will continue to be grid failures and power outages. Strategic deployment and a more localized battery energy storage system can offset the impact of these outages. Another interesting point is that we've all seen the substantial capital investment in wind and solar deployment. The grid can only take as much power as is needed, and we often have these investments not being utilized when the grid is not calling for that power. There is also the case where the power is needed on the grid, but the weather conditions do not support the source of renewables. Coupling battery energy storage systems with these renewables can expand the utilization of that capital investment.
I'll take it from. So thank you, Ray.
Thanks.
Let's ground this with the market picture. So battery and energy storage systems are no longer a niche; they're becoming core infrastructure. The global installed capacity has surpassed 200 gigawatt hour mark, with US now exceeding 26 gigawatts of installed power capacity. So in dollar terms, think of US dollar 10 to 16 billion market today across utility scale systems, commercial and residential storage, and the integration and services that make it all work. How does the trajectory look? A high growth curve with compounded growth continuing as grid modernize, renewables scale up, and resilience become a board level priority. Here at home, we are seeing concentration in a few leading states like California, Texas, Arizona, and Nevada, with New York building momentum as targets and policies mature. Here's a closer look of what the growth means in the US today. So California is leading, as you can see, with nearly 12 gigawatts installed, followed by Texas at around 7.5 gigawatts. States like Arizona and Nevada are also scaling quickly. What's exciting is the new markets are emerging, like New York, New Jersey, Connecticut, are actively building projects and setting aggressive targets. This map makes it clear opportunities are no longer limited to the West Coast. The supply chain is spreading nationwide, opening the door for manufacturers across the region to get involved. So there are four drivers that are pushing storage forward. First is the government policies. So federal and state clean energy targets are driving procurement decisions that include storage. The ITC expanded under the IRA now applies to standalone energy storage. That means projects can qualify for tax credits on total cost, with additional bonus credits available for domestic content, energy communities, and low-income areas. These incentives significantly improve project economies and accelerate adoption. Second is a demand growth, where data centers, electrification, general load growth are raising the stakes for peak management and grid stability. Utilities are deploying BESS for congestion relief, capacity, and reliability. Customers used it for demand charge reduction and backup power. Third is the corporate decarbonization or environmental goals. So large customers think hyperscalers and major industrials are using storage to meet Scope 2 and increasingly Scope 3 emission targets, while also hardening operations against outages. So last but not the least is technology and the cost. As performance improves, cost decline, more use case pencil out from past frequencies, responses to multi-hour energy shifting. So together, these drivers are creating steady bankable demand for storage and for the components and integration talent that makes it possible. On the technology side specifically, there are three themes to be watched out. First is a cost curve. Lithium-ion battery packs prices average about 139 per kilowatt hour in 2023. In 24, they are holding close to $135 to $140 per kilowatt hour, even with some supply chain pressures. Looking ahead, forecasts suggest we could see 120 to 125 per kilowatt hour in 25, with certain large-scale projects approaching even as low as 110. So this steady decline keeps unlocking new applications and improving project economies. Second is the software intelligence. We're all hearing about AI lately. So AI-enhanced battery management is extending battery life, improving round-trip efficiencies, and reducing operating costs. That means better uptime and more predictable returns for asset owners. Third is the second life and safety. Repurposing EV batteries for stationary use is gaining traction in lower duty applications. Meanwhile, safety engineering, from advanced thermal management to grid responsive controls, continue to improve, making system more reliable. So the result is clear: more hours, more safety, more value, all at a lower life cycle cost. So while the growth of BESS is exciting, it's important to recognize the challenges and concerns that come with it. First is the regulatory hurdles. Policies around permitting, interconnection, safety standards, recycling, and incentives are still evolving. That uncertainty can slow down projects and increase developmental costs. Second is the environmental impacts. Mining the critical minerals rely on lithium, cobalt, nickel, carries ecological risks. And if batteries aren't disposed of properly, there's a potential for soil and water contamination. Third is a resource constraint. Many of these critical minerals are concentrated in just a handful of countries, which raise both geopolitical and ethical concerns. Any supply chain disruption can affect cost and availability. Fourth are the safety risks. Lithium-ion batteries can pose thermal runaway hazards. Preventing these incidents means rigorous design, robust safety protocols, and ongoing monitoring. And finally, grid integration. Adding large-scale storage isn't always like plug and play. It requires complex interoperability, hardware upgrades, and careful planning to manage dynamic energy flows. This chart maps out where US manufacturers can plug into the BESS supply chain. This might be the most important slide, using high-level next categories and focusing on core component areas. I'll just give an example. Like, we'll start out with 3321, which is the first 4 digits of the 6-digit NACS code. This is where bus bars, typically stamped, come in. They connect cells with modules and modules with pack, and you will find them in both modules and packs. This is something that Ray had mentioned in one of his slides. I will not go into much detail here, but the report that Tom mentioned earlier has a much larger list, which you can refer to. The point here is that if you already operate in any of these NACS categories at quality and scale needed for energy systems, you're already closer to serving the BESS market than you might think. In the last slide, we looked at how you can plug into the BESS supply chain, the components, sub-assemblies, systems that are in demand today. But the landscape isn't static, it's constantly changing. So this slide gives us a snapshot of the major emerging technologies and from where they are and maturity on the maturity curve. At the top, we have the AI and smart BMS. These are already mainstreaming. Almost every new utility scale or commercial systems now use advanced battery management with AI optimizing performance, extending life, and enhanced safety. Next is the second life batteries, repurposed EV packs for stationary storage, followed by vanadium and ion flow batteries, which are in the early commercial technologies. Moving further along the timeline is the sodium ion batteries, which we hear a lot. They are in the pilots and early market entry. And lastly, the ion air, which are still in the pilot stage. So Energy are building systems that are deliver up to the Form Energy is one of the, I think, ion air, which are building systems that can deliver 100 hours of storage, perfect for extreme weather events and renewable thoughts. And then solid state lithium is still in the R&D and early pilots. So the key takeaway from here is that some of these technologies like AI BMS and second life batteries are opportunities you can act on now, while others are worth watching and positioning for as they move from R&D to commercial reality. On the ecosystem map, we have some key players shaping the battery energy storage. Again, I'll not go into much detail, but Fluence, Tesla Energy, NextEra Energy Resources, they're the major developers of utility scale solar and storage projects. And on the association side, we have NatBat International, and they're a US trade association dedicated to advancing battery technology and building resilient domestic supply chain. And then we have New York BEST, or New York Battery and Energy Storage Technology Consortium, who support energy storage growth through networking, policy advocacy, and testing resources, including their test and commercialization center. So this is just a snapshot. We have a much larger list of developers, manufacturers, and associations in the full report, which you can reference for deeper market research and potential partnership targets. Let me tie everything together. Storage is scaling quickly. Costs continue to trend down on a life cycle basis, and opportunities for US manufacturers are real, especially where we can retain IP and deliver quality at scale. Yes, tariffs and trade dynamics matter, but ongoing cost declines and productivity gains can help offset these headwinds when you look at the total delivered cost and reliability. With that, I can hand over to Ray for
Yeah,
his summary.
thanks, Punit. Yeah, I'd like to add a perspective on what I've seen change from the few years past as I've been involved with the battery and energy storage system supply chain and manufacturers involved in what I see now. So we referenced the investment tax credits. The investment tax credit has not had an accelerated phase out for large scale battery and energy storage systems. But with the new administration, that phase out has been touched and accelerated for other applications such as EVs and being terminated early. But the large scale battery energy storage system investment tax credit remains unchanged, except for one large part of it, which is the content or supply or control from a foreign entity of concern. That has increased its impact of eligibility for that credit. I tend to see that this, along with the tariff impacts, has changed the market and opportunity for US manufacturers. I think it will accelerate the domestic supply chain, and it will, over time, I think, provide an advantage for for US manufacturers like you guys. I will also mention that if you are a current or feel that you're part of or should be part of the supply chain, feel free to jump on that neny.org website or reach out to myself. My email address was on one of the opening slides. I'd be happy to talk to you about it. And potentially, we have a supply chain database that's free to register in and free to use, and it's specifically for battery and energy storage. And Punit, I hand it back to you.
Yeah, thank you, Ray. And thank you all for joining us today. And hopefully, we have open for questions. Matt, do you see any questions for us?
We have a few questions, and again, I encourage everybody to submit those in the Q&A pod there if you have any more. But I will put a plug to Ray and Punit on, if you have an interest in the supply chain, you think you fit in it, you're not sure, connect with them. We've made several connections, and they've been extremely valuable helping companies, make that decision, kind of a go, no go, or decide where they fit in. And check out those websites that they reference there. So definitely do that. It's well worth the time and the effort, and these guys are great. So a couple questions here, and I guess first question it's not so much supply chain, but maybe you guys can help on this, is if you're a manufacturer is looking to install battery storage at their facility for demand charges and so forth, is there a limit in terms of how much energy they use, or how would they make that decision if it makes sense from an ROI standpoint?
Yeah, there's definitely a lot of firms. I think Punit has worked with quite a few of them that help with the installations. I know that in some of the suppliers that I've worked with in New York State, I've had them make a decision within a week and go and install battery energy storage systems. We do also have a couple of good domestic manufacturers. From a business perspective, depending on the scale that you're looking for, there are solutions that are not only outside deployed energy storage systems, but there are some that have reached a point of safety that can either go on your roof or literally go inside your building. So we do have solutions like that. The credits and tax credits and things that you'll get depending on the size and scale of these, I think are going to start, the large scale things are going to keep some credits, but some of the smaller scale ones are going to be end of lifing pretty soon. So I do think engaging, and maybe again, I think Punit might be a little bit better at finding some of those people that kind of help with the deployments of those. but we can work together on it.
Okay, great. And question here, so follow up to what you just talked about. So you talked about what are the primary policy barriers, and what's the impact of less support by the federal government for the renewable energy? So you did discuss how the tax credits is still for BESS, but we might see less renewables.
Yeah, absolutely. But I think there's also a large opportunity because a significant portion of those renewables, so many of them don't have BESS incorporated with them. And, I kind of went through the logic behind that. And you got a huge investment there with those systems. And there's a lot of time. I mean, we've all driven by wind farms and seen a bunch of turbines not spinning. And, there could be a maintenance issue, but a lot of times they're not spinning because the grid's not calling for them. And when the grid does call for demand, maybe the wind's not there. So being able to utilize that and store that, I think would be a big benefit. So I do still think there's commercial opportunity here.
Okay. This other question came in email before, and it ties in, like you said, with the renewables, and we're you're talking about wind or solar. So is there a storage duration that's ideal to make this a better deployment? The question came in, I believe they said, currently maybe 5 hours of storage is good, but 10 hours to really start moving the needle for some of these deployments.
Yeah, there are varying technologies out there that can handle, larger number of hours. You could also kind of, if you think about it, if you got a 2-hour deployment capability, you could have more than one system and expand that to 4 hours. But there are technologies out there, such as the air iron that Punit mentioned. There's a big facility that was, I think it's called something like Factory One, is what they named the facility in West Virginia. That's building an air iron battery with a long duration.
Okay. Well, good. Only other question, we will be sharing the presentation. We will produce the video. So when we have that all posted online, we'll share that out with the group. And I know we have a lot of people who as well interested in knowing when that would be out there. So I don't see any more questions. So I guess I'll turn it over to you, Tom, for closing.
Ray and Punit, thank you very much. This was great information, both in the webinar, and there's even more to dig into in the report. So I just encourage everyone to take a look at what's available, and feel free to reach out to anyone at the EMA program, and we can certainly help you answer those questions and put you in contact with the right folks. So thank you all for joining us today, and keep us in mind for the future webinars on these energy supply chains. Take care.
Thank you.
Thanks, Punit.